Okay, so last section, chapter 6, phase shift sinusoidal curve fitting. So our parent function is going to be a sine omega x minus phi plus, I would call this a b, but I think that it would be a beta, B-E-T-A, beta. But I'm going to say b for all intents and purposes. So we're going to manipulate each piece of these of this equation to get the graph that we want. So when you're asked to find the period, for a sine wave, the period is normally 2 pi. Whatever our normal period is going to, when we look at a graph, whatever our normal period is going to be, so we follow our graph until it starts to repeat, and then whatever omega is, we take 2 pi and divide it by omega. So our period changes based upon this little guy here. The phi we call is a phase shift. This is our horizontal, so it moves everything left or left, right or left, because it's a cyclical function. It doesn't matter if we move it left or right. It's gonna. But we think of things in terms of moving it right. So instead of starting at its original starting point, the graph starts at phi over omega and ends at 2 pi over omega plus phi over omega. So when you're graphing, it's to highlight these little pieces here so that when you see the graph and it's giving you information, you know how to deal with it in the equation. So your phase shift takes your whole function and moves it to the right. And that's what phi represents. Highlight these formulas as well. Your amplitude is A. It represents the distance from the top of your wave to the, right now it's to the x-axis. If I bumped it up, it would be, right, so the amplitude is not bottom of the wave to top of the wave, it's just top of the wave to the center.
What's the bottom to the top?
It's 2x.
That's like the bottom.
It's going to be amplitude no matter what, because amplitude is that A value, which is positive. So amplitude is always positive. So if it's asking for the amplitude and you have a negative value here, right. Mm-hmm. The period, they call it T. It's that 2 pi over omega, and the phase shift is phi over omega. So when you're looking at the function, just the equation, you can find each of these items, amplitude, period, and phase shift. Okay, so when we have y equals 3 sine 2x minus pi, we're going to find the amplitude, period, and phase shift, and then graph. So the amplitude is 3. So if you look, from the x-axis to the top of our wave is our amplitude. That's our period is, so if we look back, I don't like that it doesn't have it over here. 2 pi over omega in our, so whatever's in front of the x is our omega. So we got 2x, so it's 2 pi over 2, or just pi, so it's going to cycle every pi. And then this minus pi means I'm going to shift everything. So hold on. That didn't explain it very well. Okay, so when we're looking at we're looking at each of these pieces. The amplitude is 3, omega is 2, and the phi is pi. So you start at phi over omega, which is pi over 2, and your period is 2 pi over omega, which is 2 pi over 2, or pi. So pi over 2 plus pi is 3 pi over 2. So your sine wave is going to cycle from pi to 3 pi over 2. And because our amplitude is 3, it's going to come up here, hit 3, hit 0 here, go down to -3 here, and end its first cycle at 3 pi over 2. And then all you have to do is continue that pattern to the left and to the right, and you have the graph of the function. So if we have y equals 3 sine 2x minus pi, we can manipulate the equation so that it equals sine of 2 parentheses x minus pi over 2. So the amplitude is still 3, and it gives us a vertical stretch of 3. So what they did is they made it look like a stretch or compress. So, and then you have a vertical compression by a factor of 2. So instead of cycling through in 2 pi, remember we take that, whatever value is in front, and divide our period by that. And instead of the sine wave cycling in 2 pi, it cycles by pi. And then the minus pi over 2 tells us that phase shift. So it tells us that this sine wave is going to shift over to the right by pi over 2. All right, so if by writing it this way, it's a way to rewrite the equation so that you don't have to go phi over omega to find the phase shift. You can just look at the equation to see that you're shifting it to the right pi over 2. All right, so now we're going to fuss with the cosine. So in this case, we got y equals 2 cosine of 4x plus 3 pi plus 1. We're going to find the amplitude, period, and phase shift. So if we look at our graph, our amplitude is 2. Our period would be 2 pi over 4, or pi over 2. And then I'm going to shift it. I'm going to start at my cosine at phi over omega. So that is 3 pi over 4. And then we're going to shift it up 1. So let's take a look at that with the same way we did look at translations. And my brain tends to want to be in this form more than trying to find phi. Whatever way is easier for you is totally fine. So if we factor out the 4, we get x plus 3 pi over 4. This tells us that instead of starting at 2, up to and over 0, we're going to start at up to that, because it's plus, boop, it's going to bump us back 3 pi over 4. I'm looking for it here, right here. And then we do the deal with the 4. So we know we're going to cycle through. Our cosine function is going to cycle through. So we're going to add, because our omega is 4, our omega is 4, so 2 pi over 4 is pi over 2. So I'm going to add pi over 2 to 3 pi over 4, and that gives me negative pi over 4. So I cycle through by negative pi over 4, and that repeats. Hold on. There it is. All right, so for this function, we have an amplitude of 2, omega of 4, and a phi of 3 pi, and then a beta of 1. So we are going to start our graph at phi over omega, which is negative 3 pi. Just note that in the original equation, this is a minus. So that makes our phi a negative 3, because negative and negative will make this positive 3 pi. So our phi is negative 3 pi. Phi over omega will give us our phase shift, which is negative 3 pi over 4. So that's this guy right here. So instead of starting at 0, 2, we're starting at negative 3 pi over 4. Our period is 2 pi over omega. Omega is 4, so 2 pi over 4 is pi over 2. To get from negative 3 pi over 4, if I add pi over 2 to negative 3 pi over 4, I get there. That means my period will end by negative pi over 4. And then I'm going to shift that up 1. So I'm going to add 1 to this function. So on my graph, I just drew a nice little dashed line here at y equals 1, and then bumped everything up so that I can see my completed graph. We can do this in the classic sense of translations, where we factor out the 4. So we can see that our period still is 2 pi over 4, which is pi over 2. We can see that this shifts it left, 3 pi over 4. I'm still going up 1, and I still have an amplitude of 2. Okay, so just to summarize, we need to find the amplitude and period. Here's the formulas for those. Amplitude is A, period is 2 pi over omega. Starting point of one cycle on the graph is phi over omega. The ending point is phi over omega plus the period. We can divide out our interval to find out what I should count by in between my phase shift and the end of my period. And then we use those 4 points to determine where we're hitting the graph. Do one cycle and then finish out. If you have a B, then go ahead and shift everything up. You can accomplish this pretty easy just by changing what you're counting by on the y-axis. So if you want to move your 0, go ahead and move your 0 down 1, up 1. So it matches your vertical shift. All right. If you're given data, like this month data, then you can find a graph that will match up to it. All right, so if we have a set of data on a table, we want to find a sine function that fits the data in this table. So the first thing we're going to do is find the amplitude. So go ahead and highlight this formula. Our largest data value minus our smallest data value divided by 2, and that will give us the amplitude. Because remember, from top of wave to bottom of the wave is twice the amplitude. So if I find that distance from top to bottom and divide it by 2, it'll give me the amplitude. If you were to draw a sine function, so once you find the amplitude, to find the vertical shift, so this is an important formula as well, to find the vertical shift, we take our largest data value plus our smallest data value and divide by 2. So largest data value plus the smallest data value, divide by 2. That tells us how far up we have to shift our function. And then to determine the period, if our period is 2 pi over omega, we just look at our data value, figure out what its own period is. So how long does it take for our data to cycle through? And when I'm talking about months, how many data points is that? 12. Right? So it's going to take me, my period is going to be 12 before I start over again for that particular month. To determine the horizontal shift, divide the period. So I divide 12 into 4 subintervals of equal length. Determine the x-coordinate for the maximum of the sine function and the x-coordinate for the maximum value of the data. And this one. Use this information to determine the value of the phase shift. So in this case, with our given data value, we get y equals 21.9. That's the max min divided by 2. Times the sine of pi over 6x minus 2 pi over 3. So omega equals 2 pi over t, so determine the period. And then horizontal shift is phi over omega. Okay, so we're going to do this a bunch of times, and you guys, your project is even based on hours of daylight again. So according to the Old Farmer's Almanac, the number of hours of sunlight in Boston on the summer solstice is 15.3, and the number of hours of sunlight on the winter solstice is 9.08. Find your sinusoidal function. Use the function found in part A to predict the number of hours, draw a graph, and look up the number of hours and compare it to the results found in part B. So here's what the graph should look like. So sinusoidal function. If we use a graphing utility, we can find the sine of best fit and then plot this on our graph. Okay, so this is the data from table 12 is the data with the temperatures in the same place for the span of a year. So your calculator can do a sine reg, a line of a graph regression function for the sine, and so taking that and comparing it to our data points, you can see it actually fits pretty well. So if we had negative 1/2 sine 4x plus 3 pi, what is the amplitude, period, and phase shift? All right, so here I have an amplitude of 3. I don't have a vertical shift, so A and C are out. I do have a phase shift, so if you compare B and D, B is, if I'm looking at cosine would start at x equals 0 and at y equals 3. In this case, that is what's happening, but I have a phase shift. So this phase shift is negative pi over 2 divided by 4, which is negative pi over 8. The only one between B and D that has a phase shift is B. So B is going to be the correct answer. And that's all for